Hello everyone, welcome back. In today's video, we're going to be taking a look at Lambda functions in Python. Now, a Lambda function is basically also known as an anonymous function. It allows you to basically quickly create little functions that you can reuse in your code without all the hassle of basically going through and building your defines and everything like that. So to demonstrate these, we're going to go ahead and start by creating a relatively simple function, and then we're going to be converting it over to Lambda, and then we're going to be showing you sort of some of the silly stuff that you can get with Lambda functions as well. So what I'm going to do today is I'm going to create myself a function called add. That's going to be very, very simple. I'm going to pass two values to it, x and y, and I'm simply going to return x plus y. The purpose of this basically is going to be to add these two variables that we add and basically send it back. You're sitting there going, okay, that's pretty elementary. Can you give us something more complicated? Not yet. You'll see what I mean. So to test this, of course, I'm just going to go a quick little like this. I'll say add 5 and 10, and we'll print a result. And of course, we expect the result here to be 15. We're going to take 5, 5, 10, 10, 5 plus 10, 15, return, bam. Let's see what happens. Bang. And we can see we get a value of 15. So it works. That actually is pretty good. Not bad. Not bad. So what we're going to do is we're going to convert this into a Lambda function. Like I said, it's those small anonymous functions you can use inside of Python. To do this, I'm simply going to go ahead and type in the name of the new Lambda function. I'm going to call this one addl. I'm going to write equals, and now I'm going to type in the keyword Lambda, and then I'm simply going to define the different components of it. Lambda functions are made up of two parts, the values that you send, which are your parameters, and of course the values that you return, which are relatively straightforward. Those are going to be separated by a colon. So in our example, we're sending in two parameters, x and y, colon, and we're going to return something. Now, if you remember up here, we're returning x plus y. So to make that as a return inside of a Lambda function, I'm simply going to do x plus y. My Lambda function is done. So now if we wanted to test to make sure it works correctly, I'd simply type in results, addl, and we're going to use it identically to the way that we did it a moment ago. So now if I print a result like this, go ahead and press that lovely run, you will see that I get 15 both times on account of the fact that it works exactly the same way. Now you're looking at that going, oh, okay, so why would I ever use Lambda functions? I mean, I'm taking a look at that real quickly here, and is it like I'm just saving time? And again, it depends sort of on what you're trying to achieve with a particular function. So let's go ahead and create another one. So one of the functions I really like to do is I like to have a tool that rolls a dice for me. So let's go ahead and build that as a traditional function. So I'll do a def roll, and I'll go ahead and say num sides, which will refer to the number of sides on the dice. And of course, we're going to have to get ourselves a copy of the random library. And yes, we'd never put this down here. I have to actually drag that and put it up top. You know how these things go. So what I'll do here is I'll go ahead and define it. I'll make a quick little roll. I'll return. Let's see here. We need random.randint. Again, good review from last time. Num sides. And we're ready to go. So now if I wanted to actually test to see if this function works, I could just say dice equals roll 6. Print dice, and theoretically, every time I run this, I should get a pseudo-random number. First time I ran it, I got a 4. Second time, I got a 3, 5. So it is working correctly. Now, let's go ahead and take this entire function and compress it into a Lambda function, just to make our lives a little bit simpler. So again, I'll do the exact same thing. I'll call this don't need to def. I'll just type in roll L. Roll Lambda, and we're simply going to go ahead and type in everything we did before. We're sending in num of sides, and we're returning our random. Let's go ahead and be maximum lazy here. And that's all there is to it. So now if I wanted to test this one, it would work exactly the same way. Roll. Roll 6, print dice. And theoretically, if we run this one, we should get the exact same kind of output. Obviously, the numbers should be random every time we run it, and you can see it's more or less random. But you can see how we took this big function and we basically shrunk it down to something that's one line. And I can use this one over and over and over again if I need to use it, which is kind of one of the neat little tricks that we have here. Now, you're sitting there going, all right, that's not bad. That's not bad. But is it like, can you give me another example? You know, like something that's like, oh, can we have some fun with this? And the good news and the bad news is the fun examples usually involve things we haven't gone over yet, things like lists and dictionaries and like all sorts of key value pairs. But believe it or not, one of the really practical uses of these is actually making quick decisions. Let's go ahead and make a really classic function here. I'm going to say is even. And I'll set number as my value here. Now, we haven't done conditionals yet, but I'll go ahead and put this one in here. I'm simply going to say if, let's see here, number %2 equals 0. That means we're dealing with a noun. We'll go ahead and return true. And of course, we'll return false. Now, many very sharp-eyed folks would immediately say, you forgot the else statement. We don't need the else statement because logically, if it's not true and it gets sent, it has to be false. So there's no other mathematical solution there. So if I wanted to test this real quickly, I could say is even. We'll do 4. We know that's even, so I expect it to go ahead and say true, which it did. Let's go ahead and change that to 5. Let's run it again, and you can see false because it's not. So I've built a nice little is even function here, and it actually works pretty well. Wouldn't it be cool if we could shrink this into a lambda function? Yeah, let's do it. So I'm going to come down here, and I'll call this one is even L, because why not, equals lambda. Okay, now we're in trouble. What are we sending? Number. Okay, what are we returning? Uh-oh, what do we do? How do we put an if statement in one line? And again, we haven't done those yet, but we'll do the short version. So what I'm going to do is I'm going to write in the value if it's true. So in this case, true. And then I'm simply going to write if x, actually not x, it'll be number. Whoa, yeah, I've done that correctly. If number percent 2 equals 0, else false. Hey, look at that. Let's work this out for a second here. We're sending a value of number. We're saying return true if the number is divisible as even, I should say, divisible by 2 evenly. Otherwise, return false. Okay, that's actually pretty cool. Let's see if it works. Print is even L. That's so goofy. Let's see here, 4. So we expect this to say true down here. So if I run this, bam, true. If I come up here and push a 22, I expect true again, correct. Then make this 11, run it again, false. That makes perfect sense. All these different values actually check out, and you can see how we can make that nice and small. Now, where lambda functions can start getting themselves a little complicated is if you wanted to try to create some sort of variable in the lambda function. Now, I personally would argue that if you need to do this, you probably don't need a lambda function for this. But the reality is you actually can create variables in a lambda function. So let's do something really goofy. Let's create a function that basically doubles it if a value is greater than 5. So let's create it. So we'll do this with a lambda if greater than 5. That's not pretty easy here. Equals, we'll do lambda. So we need to pass a value here. So we'll pass a value. We'll call it value. Keep it simple for us. X. So what I'm going to do here is I'm going to create a temporary variable to basically check it. Again, I want to return the value changed if it's greater than a certain number. So I'm going to create myself a variable here. I'll call this one y. And I'm going to use a really funky thing called the walrus operator, the assignment operator. And I'm simply going to assign it to a value of the input value, which remember is value, times 2. Now your brain is going, wait a minute. So you're creating a local variable. You're assigning it to my input value times 2, but we only want to send it if it's greater than 5. So how are you going to do that? Aha! I see what you did there. Value greater than 5. Else, we're going to send back the original value. Whoa. So what we've actually done here is we've created a temporary value called y, and this is going to be the value we send back if that value is greater than that particular point. If value is greater than that. Kind of funky, huh? Now watch what happens here. Now this is where you have to be a little bit careful here. Oh boy, this is going to get a little messy. Result equals double, man, this is garbage. 10, print result. Now watch what happens. You will notice that it says 20. Because our value is greater than 5. So that's going to be the value we return. So now if I came here and said 2, we expect this to not be doubled. If I go ahead and press my run key, you'll see it says 2 because it is indeed less than 5. Now you're sitting there going, okay, that's okay. That's you're getting a little technical here. Wouldn't this be just easy in a function? And again, I would say yes. But believe it or not, these lambda functions have other places, but that is going to be saved for when we start getting into conditionals. And we'll take a look at match case, where you can put a lambda function into a replied result. But we'll look at that later. Enjoy.